Hello, good evening, students, and good morning to also. See, this is your e-learning session, and it is initiated by Vidyadish Vidya Sankul under the guidance of Dr. G. M. Sutaria, sir. See, in our last lecture, we complete up to illustration number 17. Okay, and I also gave you the homework that 1.2 exercise, 1 to 5 questions, then 1 to 5 questions and 6 to 15, total 1 to 15. All the questions I was give you in your homework. I hope you all complete that. Some students send me their doubts in WhatsApp. I am here now. After illustration number 18, I am solved that 2 to 3 sums are there. Which are doubts, please send me the next doubts, or then call me or WhatsApp me. Okay, now see, we will discuss about illustration number 18 in this lecture. Okay, now we will start this lecture. Okay, I am reading that. A box contains 10 cheats, of which 3 cheats are eligible for prize. See, in one box, total 10 cheats are there, and from that 3 cheats are eligible for prize. That means in 3 cheats prize is there, and remaining 7 cheats are non-prize. That is, on the 7 cheats not eligible for the prize. Okay. Now a boy named Kathan randomly selects 2 cheats from this box. See, out of total 10 cheats, Kathan select 2 cheats. That's why total number of outcomes is equal to 10C2. Okay. Find the probability that the Kathan gets the prize. Okay. We want that Kathan gets the prize, whatever the condition is there. See, in total 10 cheats, 3 cheats are eligible for prize, the 7 cheats are not eligible for prize, and the probability of getting what? See, Kathan gets a prize. See, they indirectly say that on 1, on 2, any. See, Kathan select only 2 cheats. See, in previous sum, in illustration number 17, total 20 items are there, and we have to select 3 items, and in the event 2 items are say defective or non-defective is there. Okay, so here the less items are there given in the events. Here total 10 cheats, out of 10 cheats 3 cheats are eligible for prize, but here Kathan has to select only 2. That means here less in the total number of outcomes. In the previous sum, total number of outcomes is higher than the events. Here in the events is also lower, but the total number of outcomes is also less. That means here 3 cheats for the prize, eligible for the prize, and Kathan has to select only 2 cheats from that. Okay, so here the twist are there. So please read this question again and again and understand that, and then give the answer. So here in the probability, the main thing you have to concentrate, that is the question. You have to read each and every point of the question. First of all, understand that, and then give your answer, please. Okay, now we'll start. Illustration number 18. Total 10 cheats. Out of them, 3 are eligible for prize, and 7 not eligible for prize. Okay, so total 10 cheats. From that, 3 are eligible for prize and 7 are not eligible for the prize. Now, total number of outcomes. N is equal to, see, from 10 cheats, Kathan has to select only 2. Okay, so 10 C2 is the total number of outcomes. Okay, so what is the final answer? 10 into 9, 2 into 1 divided by that, so 5. That's why 45. 45 is the total outcome. That is your N is 45. Okay, now what is the main question? See, read that question carefully. Kathan gets the prize. See, in one cheat, if they get the prize, your event is over. And in both the cheats, if they get the prize, the event is over. So here 2 possibilities are there. 2 possibilities. What the first possibility is what? Here on one cheat he gets the prize, on the second cheats he didn't get the prize. That means here first cheat from the eligible, 3 cheats of eligible prize, and 1 cheat from the 7 cheats which are not eligible for the prize. So 2 cheats but from 2 different ways. See here, from from eligible of prize, 3 cheats, we are Kathan selecting 1 cheat, and from non-eligible 7 cheats, Kathan select 1 cheat. That is here 3C1 into 7C1. From that, see, total 2 cheats are selecting but by Kathan, but 1 from eligible of prize and 1 from not eligibility of the prize. And the second possibility, or see, now not and, or the second possibility is that here he gets 2 cheats from all 3 cheats of which are eligible for the prize. So the total, see, and or both are here. So here whenever and is there we have to multiply, whenever or is there we have to add. Okay, so see, event A, Kathan gets the prize. So the total outcome, or you can say favorable outcome. Favorable outcomes of event A is equal to, favorable outcomes of event A, AM is equal to, here, see, the main thing, see here in the question, in the answer, they are using a different way. Don't see the answer here in probability. Now in all the sums, don't see the answer because they are using a different ways. Okay, they are using a different method, but I am giving you here the easiest method. So please keep in mind and use your mind for this method, please. Okay, see, favorable outcomes of event A, that is M is equal to, whatever I told you that. First, the first possibility, what is the first possibility? Kathan gets 1 cheat from this and 1 cheat from this, and okay, so here the first possibility that Kathan select 1 cheat from the prize and 1 cheat from not eligible of prize. But ultimately the point, that is event is complete, Kathan gets the prize. Yes, on 1 cheat or on both the cheat, whatever is there, but the main point is Kathan get the prize. Yes, here on that 3C1, Kathan gets the prize from 3 cheats, that is 1 cheat selecting from this and 1 cheat of not eligible for prize. That doesn't matter. he get the price here, or the second possibility, that means or means plus. First possibility, he is selecting one from these and one from these. That is the first possibility. Now the second possibility is he is selecting both from eligible for price. That is 3 cheats from 3 cheats which are eligible for price. Kathan selecting 2 from that. See what is the third possibility, which we are not using here, but I am just giving you, or I am just explaining you here. The third possibility may be plus. Third possibility, whenever, see, 1, 2 or 3, total 3 possibilities for this experiment. Okay, here the third possibility is Kathan selecting 0 cheats from this and 2 cheats, all 2 cheats from non-eligible for price. But here in this case, see, in this case Kathan did not get the price. Okay, Kathan here will not get the price because here no cheats from eligible of price. Okay, here both cheats are non-eligible of for the price, and that's why it is not our criteria, it is not a favorable outcomes of event A, because event A is what Kathan get the price. Here whatever the condition is there, here the condition is fulfilled, here also the condition is fulfilled, but here the condition is not fulfilled. Okay, so here you can say, see, you can write here into 7C0. Why? 7C0, why? (3C2) into 7C0. What means of that? See, NC0 is equal to 1. I told you in my second last lecture that whenever NCN is equal to 1, NC1 is equal to N. Okay, and see here NC0, 7C0 is equal to also 1. Okay, so please, 7C0 means what? See, 3 possibilities, total 3 possibilities are there. Kathan gets 2 cheats from this, no one from this. Kathan gets 1 from this and 1 from this. And the third possibility is no cheats from this, only 2 cheats from this. Total 3 possibilities are there. Okay. So here, first possibility that Kathan gets 1 from these and 1 from these, or means that's why plus. Or the second possibility is Kathan gets 2 from these, no 1 from these, or Kathan gets 0 from these and 2 from this. But here in this, the condition of event A, that Kathan gets the prize, is not fulfilled. That's why we don't have to write these as your favorable outcomes. Here it is not a favorable outcomes because in this case Kathan did not get any prize. Okay, so your favorable outcomes is only this 3C1 into 7C1, or that is plus 3C2 into 7C0. Okay, what is the answer now? 3C1, NC1 is equal to N, that's why 3. 7C1, that is 7. Okay, plus 3C2. 3C2 is equal to 3 into 2 into 2 divided by 1. And 7C0, NC0 is equal to always 1. So here the answer is 7 3s are 21, or here 2 cancel, so 3 into 1. So you can get 21 plus 3, that is 24. Your favorable outcomes for this event, is 21, and therefore here the P of A is equal to M upon N, that is 24 by 45. And here, see, in the table of 3, the common we can take on 3 from this. 24, that is 8 3s are 24, and 9, that is 15 3s are 45. 3 8 3s are 24, so we are cancelling this, and 3 are taking a common. 8 3s are 24 and 15 3s are 45. That's why 8 by 15 is your final answer, and therefore you can say that required probability is equal to 8 by 15. Okay, see the answer now. In the textbook, see the answer. The answer is given in a different way. They are taking P of A dash. A dash is equal to M upon N, that is 21 by 45, that is 7 by 45, and then P of A 1 minus P of A dash, that is 1 minus 7 by 15, that is 8 by 15 is the final answer. But they are taking A dash in a different way. Also, that's why it is very difficult, it is very confusing. So for you, the final answer, see, we get the answer which are the method is we are using, but main thing is that we have to write down the correct answer. That is the main thing. Okay, so here the easiest way, that is event A, Katan gets the prize. There are total 3 possibilities, but from these 2 are the eligible for our event A. Here you can say favorable outcomes for event A, that are, see, from these 3 we are taking 1, from these 7 we are taking 1, or that is first, whenever we are saying or, we have to write plus, or whenever we are taking and, one from these and one from these, the main answer is one from these and one from these, that's why total 2, or 2 from these and 0 from these and 0 from these, that is a total, we are selecting total 2 from the 10 cheats. See here, 1 from these and 1 from these, that's why we are selecting 2 from these and none from these, again we are selecting only 2, and the third possibility, none from these and 2 from these, that is also we are in the second next possibility, that is in third possibility we are selecting only 2 cheats, and that's why 3C1 and 7C1, 3 7s are 21, 3C2 that is 3, and 7C0 that is 1, 3 into 1, 21 plus 3, that is 24, and now the sample P of A is equal to M upon N, that is 24 by 45, 3 is common, 8 3s are, 15 3s are, 8 by 15 is your required probability. Okay, so it is very easiest way and very easy sum, but here this sum will ask in 3 to 4 marks, so please write down this is your most favorite, and see, it is very important sum also because it was asked in your previous examinations 2 to 3 times. Okay, so it is also important, please write down this. Okay, so I hope this complete. Now in exercise 1.2 I was give you 1 to 15 sums, and see, some sums are difficult to you, so I am here explaining you 1.2 question number 5 and the next. See, but first of all we are saying that we are doing that exercise 1.2 question number 5. Read the question first. The sample space for a random experiment of selecting U is equal to 1 to 120. U is equal to what? 1, 2, 3, 4, 5, 6 up to 120. Right? And all the outcomes in sample space are equiprobable. So the probability for that is NC1, that is here we have to selecting. See, find the probability that the number selected is one number is selecting from that. That's why the total number of outcomes U is equal to N 120 C1. We have to selecting here. That's why the selection is there. That's why the combination is used here. That's why the main total number of outcomes N is equal to from 1 to 120. That is 120 numbers. We have to select one from that. That's why here we can say that 120 C1. Okay. So here I am doing that. Please Exercise 1.2. Sum number 5. What is your total number of outcomes first? N is equal to what? From total 120, we have to select one number. That's why NC1 is equal to N. That's why 120 is your total number of outcomes. Okay. So this is your N. Now, what is the event A? First point, event A is equal to the number selected is a multiple of 3. Okay, now see that multiple of 3 from 1 to 120. See, we have to find out how many numbers are there is multiple of 3. See, we can do in your rough work. See here, this is not your part of your answer. Please, I am doing the rough work and because of your better understanding, right? See here, how many numbers are there? Total 120 numbers are there, and which are multiple of 3 means what? Here we have to find out. So see, we have to divide with 3. How many numbers are there? Total 40 are there. See, we cannot say that 3, 6, 9, 12, 15, 18, 21. We cannot count them. Right? Here we cannot count. If we are counting them, that it is very time wasting of time. Right? So here we have to just find out in different way. See, we have to do a rough work. What is that? 120 divided by 3, because multiple of 3 means what? How many numbers are multiple of 3? See, we have to consider the integer. If the answer is in fraction, then we ignore the point. We have to just take the integer point. See, if the answer, see, say for example, if the answer is 40.50, then we have to ignore this. 0.50 we have to ignore. We just have to concentrate on the integer 1, that is 40. So here the answer is 40 exactly. So we don't have any point, any problem. So the answer is here 40 is that. So favorable outcomes. Of event A is equal to M is equal to what? 40. From that we have to select one. Total 40 outcomes are favorable from that, and we have to just select one only. That's why 40 C1. That's why 40 are M, and therefore your P of A is equal to what? M upon N. 40 divided by 120. That is 1 by 3. So required probability is equal to 1 by 3 is your final answer for your event A. Okay. So here your event A is over. Now what event B? Second point. It is not event B because here the second point is not a multiple of 3. What means of that? Here A dash. The number selected is multiple of 3, and if the next event is the number selected is not multiple of 3, that means it is a complementary event of event A. That's why we can say it is not event B, it is event A dash. That means the number selected is not a multiple of 3. So what is the final answer? See, here we don't have to find out the favorable outcomes of event A dash, because the formula for B of A dash is equal to what? 1 minus P of A. See, event A, if we are selecting that the number is selecting by is multiple of 3, and the second event is given that the number selected is not a multiple of 3, that means it is event A. If we are supposing this first event as event A, then your second event is not event B, it is your A dash. That is event A's complementary event. That's why here we are using not this method, we are using this formula. P of A is equal to 1 minus P of A, P of A dash is equal to 1 minus P of A is equal to 1 minus 1 by 3, and we are taking 3 as LCM. So 3 minus 1 by 3. So 2 by 3 is your final answer. Therefore, you can say that required probability is 2 by 3 is your final answer for event A dash. That means for your second question. Okay, whenever they say that event A is equal to number selected is a multiple of 3, and second event that the number is not multiple of 3, that means it is not event B, it is a complementary event of event A. Okay, now the next question. Now it is event B. Why? Because the different question is there that number selected is multiple of 4. Again, in rough work, we have to calculate that how many numbers are multiple of 4 from 1 to 20? It is 30. Right. So here, the favorable outcomes. Therefore, favorable outcomes of event B, M is equal to what? Favorable outcomes of event B, M is equal to what? It is, see here, how many numbers are there which are multiple of 4 from 1 to 20? 4, 8, 12, 16, 20, all are that, but we don't have to write that, we want numbers. Numbers is there, 120 divided by 4, that is 30. So from 1 to 20, 30 numbers are there which are multiple of 4, right? So here 30, from this 30 we have to just select one, that is 30C1, that's why 30 is your NC1 is equal to N, that's why 30 is your favorable outcomes, and therefore you can say that P of B is equal to what? M upon N, that is 30 upon 120, and that is 1 by 4, because 30 is the common, and then you can say that required probability is equal to 1 by 4. Got this? Right. What is your event? The number selected is multiple of 4. Right. That means what? The favorable outcomes of event B, M is equal to what? From these 1 to 20, U is equal to 1 to 20. From 120 numbers which are the multiple of 4, 30 numbers are multiple of 4, and from that we have to just select only one. That's why favorable outcomes is equal to 30 C1, that is 30. Now the P of B is equal to M upon N is equal to 30 by 120, it is equal to 1 by 4, and that's why required probability is 1 by 4. Okay, now fourth point, again not multiple of 4. Here we say that just like this, we have to write event B dash, not event. See, event A is equal to selected number is multiple of 3, A dash not multiple of 3, B selected number is multiple of 4, and B dash not multiple of 4. That's why event B dash, the numbers selected is not multiple of 4. Therefore, we don't have to use these favorable outcomes and so on. We just have to find out by different way, by different formulas. That is P of B dash is equal to 1 minus P of B is equal to 1 minus 1 by 4. We are taking 4 as LCM, so 4 minus 1 by 4. That's why 3 by 4 is your final answer. And we can say that therefore required probability is equal to 3 by 4. Okay, so here 4 events, 4 points are complete. Event A, number is selected multiple of 3. Event A dash, number selected is not multiple of 3. Event B, number selected is multiple of 4. Event B dash, number selected is not multiple of 4. And now the fifth and the last point is a multiple of both, that is 3 and 4. So here what is the event? First of all, and is that, that's why we have to use the intersection. But here what is your rough work? How can you find out all the numbers which are multiple of both 3 and 4? See here, the shortcut is 120 divided by 3 and 4. Multiple of 3, then we are dividing 120 divided by 3, that is 40. Multiple of 4, that's why we are dividing 120 divided by 4, that is 30. But a multiple of 3 and 4 both means what? 120 divided by, and is there, that's why we have to multiply 3 and 4 both. That's why what is the answer? See here, 120 divided by 12, that is 10. So the 10 numbers, see which are that? See, multiple of 3 and 4 both are 12, 24, 36, 48, 60, all are that. Okay, etc, etc. That is last 120 is also multiple of 3 or 4 both. 3 and 4, sorry, 3 and 4 both. Okay, so now the next point is event A intersection B. A is multiple of 3, B is multiple of 4. But here multiple of both 3 and 4, and for that and, the word and, we are using intersection. Okay, so here I am writing that the number selected is multiple of both 3 and 4, right? And therefore the favorable outcomes sorry for the interruption. So here favorable outcomes, what is that? Favorable outcomes of event A intersection B is equal to, M is equal to, how many are there? There are 10 numbers. So 10 C1 is equal to 10. Therefore P of A intersection B is equal to what? M upon N, that is 10 upon 120, and that is 1 by 12. So here you can say that the required probability for event A intersection B, that is multiple of 2, 3 and 4 both, is 1 by 12. 10 is common from numerator and denominator. That's why the probability, total probability is 1 by 20. Okay. So here, what is your final answer? For the number selected is multiple of both, that is 3 and 4. That is what? Here it is A intersection B, event A intersection B. And for that, what is the favorable outcome here? 10 numbers are there which are multiple of 3 and 4. And that's why we can say 10C1 is your answer. 10C, that is your favorable outcomes, that is 10. And from that, what your final probability is, P of A intersection B is equal to M upon N is equal to 10 by 120 is equal to 1 by 12. So you can say that the required probability, you have to write that here, required probability for selecting A and B, sorry, that is A intersection B, that is multiple of 3 and 4 both, is 1 by 12. Okay, so here your doubt for exercise 1.2 is over. Fifth question is over. Now your remaining doubts is, here we are discussing in our next lecture. So, but first of all, see, we are just discussing about illustration, question number 6. Here I am not doing that particular sum. Here just I am explaining you question number 6, and some odd doubts are there, but we are discussing that your doubts in our next lecture. But your today's homework, see, time for homework. You have to write all the sums, that is exercise 1.2 full in your exercise book. That means here in our previous lecture I was give you from 1 to 15. So whichever are remaining after that 16, 17, 18, as well as if 3, 4, 5 are remaining, then please write down. There's all the sums of exercise 1.2. You have to complete that in your exercise book. And I am discussing here your question number 6, which are the arrangement for which are the permutation sum. See, find the probability of getting R in a first place and M in the last place when all the letters of the word random are arranged in all possible ways. Means what? Here the word random, in that 6 letters are there. So total number of outcomes is equal to what? We have to arrange here. We don't have to use the C, that is combination. We have to arrange the word RANDOM, that is 6 letter we have to arrange in a different ways, and for arrangement we have to take permutations, right? So 6 letters are there, 6 places are there, that's why we have to arrange that in a 6 different ways, that is 6p 6 ways. 6p 6 ways, that is 6 factorial. 6 factorial means 720. That is your n is equal to 720. Now here R in a first place, that's why one place and one letter is fixed, that's why 1p1. R on a first place, that means R is a one letter and place is also fixed, that is first place. So 1p1 for this. Second condition, and that's why multiply. Second condition, M on the last place, that's why one letter and one place is also fixed here. So 1p1 for R, 1p1 for M. Both are fixed, both letters and both places are fixed. Here R on the first place compulsory, M on the last place compulsory. So 1p1 1p1 both, for both 1p1 1p1, and the remaining 4, between these two remaining 4 letters are there, and between these two 4 places are also there. That's why in different 4 places we have to arrange 4 different letters in 4p4 ways. That's why we can say 1p1 into 4p4 into 1p1 is the favorable outcomes of event A. See, again I told you that here in favorable outcomes of event A are for R 1p1, for middle 4 letters 4p4, and for M last 1p1, 1 factorial, 4 factorial, 1 factorial. 1 factorial answer 1, 4 factorial answer 24, and the last 1 factorial again 1. 1 into 24 into 1, that's why 24 is your favorable outcomes. And here from 24 divided by 720, sorry, P of A is equal to what? M upon N. 24 divided by 720. That's why 1 by 30 is your final answer. So your exercise question number 6. Here the sixth question, here random is selected, random is arranging in all different ways, where R is on first place and M on the last place. That is the probability. And see the seventh one, find the probability of getting vowels. See how many vowels are there. From that, all the A, B, C, D, E, F, G, total A, B, C, D, A to Z, how many vowels are there, and we have to arrange. See that here, find the probability of getting vowels in the first, third and sixth place. First, third and sixth place, we have to write down all the vowels, right? When all the letters of the word orange are there in all possible ways. See how many vowels are there? O, A, E, I, O, U, right? All are there, and we have to arrange that in a different place. Here 3 vowels are there, and here have to arrange that 3 in a different 3 ways. So 3P3. And for the different 3 remaining 3 words, 3 letters, we have to arrange in the 3 places. So your total, first of all, your total outcomes, 6 letters are there again, and 6P6, that's why 6 factorial, that's why 720 is your N. Here 3 vowels, 3 places, 3 remaining letters, 3 places, 3P3 into 3P3, that is 3 factorial into 3 factorial, that is 6 into 6, that is 36. So 36 divided by 720, that is 1 by 20 is the answer of question number 7. So here some difficulties, more difficulties are there. We are discussing that difficulties in our next lecture. Okay, so here I am complete my lecture here, and the remaining difficulties of exercise 1.2 is we will discuss in our next lecture. Up to that, you have to complete in your illustration books 1 to 18 illustration, and in your exercise book 1 to 1 exercise 1.1 as well as exercise 1.2, and leave the page if you have any doubts. For that I am doing that on the board, or I am giving you the explanation on phone calls or WhatsApps. Okay, so here I am complete my lecture. Thank you class.